All right, so we are going to go over the warm-up, and then we'll talk about what we're doing for the rest of the class. There's not a huge agenda today, but we have a few things to do. So is it a function? Hey, everyone, what do you think? Is number one a function, yes or no? Literally just yell yes or no. Oh my God, guys, you have masks on. I don't even, just someone yell something.
No.
Oh, no. Does anyone think yes? No one thinks yes? You sure? Positive? This is a function. Oh my God, I totally tricked you guys. Wow, what a day. This is a function. Hey, so before we actually move on and say why, does anyone know what a function is? You've heard the word a million times. People say linear functions or whatever functions. But yeah, we need to actually know what a function is. So let's write that first. I would suggest writing this down if you don't know, because you are going to need to. So the book makes it like super complicated. I'm going to give you like the very simple version. A function is when every input has only one output. So if you want to replace input and output with x and y, every x has only one y. So what you're looking for, I think a lot of you looked and you said, oh, like you saw 3 repeating here and then a 6 repeating there. You knew that you were kind of looking for something repeating. I only care if the x's repeat. If the y's repeat, that's fine. They can all have the same y. But see how all of these x's are different values? You're good. It's a function. So that's what you're looking for. Excuse me. Talking too much today. So, like, most basic definition, every input has one output, so every x has one y. If all your y's are different, it's an automatic function. So you're good. So taking that same idea, number 2, what do we think? Yes or no? Let's yell it out.
No.
No. Does anyone remember something called the vertical line test? You like held the pencil like this. I feel like everyone remembers that for some reason. The vertical line test tells us that if a vertical line goes through more than one point, it is not a function. Basically, it's just saying that this x has more than one y. It has 3 y's, so that's why it's not a function. This is called a mapping diagram. It's just a fancy way to write points. My brain doesn't process them, so I always write things as points. So this is the point 1, 3. This is the point 1, 4. This is the point 2, 5. So it's just mapping an x to a y. The one thing I'm looking for is do any x's repeat, and they do. This one has the same x, so this is an automatic no. Okay, so that's what you're always looking for when you're telling if something is a function or not. Does the x repeat? Same thing here. All of these x's repeat, so that would also be a no. So you probably talked about functions in some part of your math career, but it's always good to redefine things. I was just seeing if you can remember. Have you guys, just like vocab, because these are words that I'll say, have you heard the words domain and range before?
Yeah. Yes.
Okay. So just as a reminder, if we talk about domain and range, the domain is just the input values. So we call it, usually those are our x's. And the range are our output values. We call as y. Sometimes we'll be using function notation, so we might call it f of x. So if I ask what's the domain of this, you would literally just list the x's. If I ask what's the range of this, you would just list the y's. So just vocab-wise, if you hear those words, I'd rather remind you of them than assume that you know them. So that was the first part. Pretty cool. The next thing we're going to be doing is looking at transformations. So we're going to talk about parent functions. And we're going to do a little bit, there's some graphing where I'm not going to make you do like 20 graphs today because that would be a little bit aggressive. So I'm going to do a graphing calculator up on the board, and we'll just kind of look and see how different things are transformed, and then we'll come up with some rules for them. So before I start, because you'll hear me say parent function a lot, I just like to give you an idea of what I'm talking about. So we're going to be talking about different functions. In a parent function, It's just the simplest form. Let me write first and I'll talk. In the set of functions. That formula failed. Okay. So an example of a parent function is if I'm talking about linear functions, we've all dealt with lines before. The simplest linear function is just y equals x. There's nothing happening to it, it's not moving, it's not going anywhere. So we call it the parent function. For quadratics, it would just be y equals x squared. There's no coefficients, there's no constants, nothing's being added, subtracted, anything. So basically the parent function is just the simplest form to which we are going to now translate. So we're going to move it around. So I'm going to put up my graphing calculator. It's called Desmos if you've ever used it. If you don't have a graphing calculator, it's nice to just have access to something, especially if you have to do like a million graphs. It's just nice to see things quick. So I'm going to put this down. Too glary for you. Turn my light off so you can see a little better. So we're gonna, how's if I turn the projector on? I was just gonna do the whole thing without the projector on. Where's my, okay. So we're gonna start with the parent function y. Y equals x squared, so that's called a quadratic. You've dealt with quadratics before in the past, but we'll just look a little bit more into detail of the graph and how to translate it. Let me get it up for us. Okay. All right. So you can see off to the side, I wrote the function y equals x squared, and now I can see the graph of it. Does anyone remember what this graph is called when you have that U shape? Parabola. We have a nice parabola there. And our main goal is we want to translate it. We want to move it up, down, right, left. We want to make it narrower. We want to make it wider. We want to flip it. So we're just trying to figure out ways to do that. So instead of me just telling you, it's nice to kind of just look and see what happens. So we're going to leave this one up. That's our parent. That's like the original. If I said I wanted to take that parabola and move it up 3 units, can someone guess what I would do? Yep.
Y equals x squared plus 3.
Yeah, so let's try it. That's why this is nice, because we can actually see if it works. Oops. We have our original. If I just add a constant on, it's just going to pick that parabola up and move it up. Okay. Hey guys, if I wanted to move it down 3 units, what should it do?
Y equals x squared minus 3.
Yeah, exactly. I can just put a minus for down. Okay. So that's our first translation. I'm going to start to write them over here, so I would write these down, just because there's going to be a lot of them in the end. And it's nice to just have it in your notes somewhere, so you can know you can always refer back to it. Try to spot in the stools. Okay, so these are all the translations. So these are going to be the vertical, so that's when we move up or down. I'm going to write it first, and I'll tell you. So I'm going to write it, and then we'll talk about it. And I'll move. I know I'm probably in your way right now. Okay, so now I'll move so you can actually copy it. So when we're talking about translation, so we call that vertical because we're moving it on the y-axis. If we want to move it up, so f of x is just our function. In this case, it's x squared. It could be anything. We'll talk about absolute value functions. You can do cubics. You can do radical functions. There's all sorts of fun stuff. So if I take my function and I just add a constant to the end, we're calling that k for now. That's going to move it up. And if I take my function and I just put that constant by subtraction, that will move it down. Kind of makes sense. Yeah, so when you move it up, you subtract, you move it down. Okay, so that was exciting. Now here's my question. I have a quadratic, I have my parabola, but I want to move it to the right. Does anyone know how to do that? Yeah?
You add to x in parentheses, so like,
Okay, so you said you would add to x, so let's say I'm moving it 3. We'll keep it 3. When I added, what way did it move it? To the left. So it's kind of freaks you out. So when you're in the function, you have to do the opposite sign. So we'll write that down. So when we're inside the function, we have to do it to the opposite sign. There's all stuff we'll talk about later. We have to set it equal to 0. But that will be part of our translations that we write. So inside the function, in the parentheses, if we move it or add or subtract, that will move it right or left. So I'm gonna write that over there. Sorry, I'm running back and forth. I lost my paper. It's over here. So we call those horizontal translations, because we're moving it right or left. Once again, I know I'm in the way. I will move in a second. For horizontal, so we use K. For that, we use H for this. HK eventually becomes our vertex. All will magically come together. But if we're going to translate it to the right, I'm going to say H units. So we're just changing it just for the representation. We would write it as Y equals F. And then in parentheses, we would write X minus H. And if we want to translate it to the left, H units. You would take your function, and in the function, we would add H. So I'll put that up first, that'll be up, so feel free to write it down. But that's how you're moving right or left. Okay, so you're probably thinking, okay, up, down, right, left, like what else can you really do? But with a parabola, or with different shapes, we can change how narrow or how wide they are. So if you think about a U, you can make a U really skinny, you can make a U really fat. So we'll talk about that, and then the last thing will be reflection. So these things I'm just gonna do, and then I'll write it after. So don't feel like you have to write it, like rush to write it. I will write it down for you in a second. So what's happening is we can take this function, but we can put a coefficient in front. So we've seen that before. You guys have done quadratic stuff. So if we put a coefficient in front greater than 1, what's going to happen? So the blue, or our original is red. When I put a coefficient in front, if I put 5, that blue one is getting skinnier. And the higher the number I make it, the skinnier it's going to get. You can make it, 120. Oh, we can make it 1200. It doesn't matter. So it's getting skinnier and skinnier to do it. We call that stretching it. My last class, I kind of confused myself too. When you think of stretching, I feel like some people think of going that way. I always think of stretching my hands. If you're like this and you stretch up, you're going to go up like that. So just kind of keep that in mind. We were thinking about it differently last period, and then I confused myself. So a stretch is going to make it narrower. And then you can probably guess, if we want to make it wider, we want to kind of do the opposite. So instead of making the number really large, we're going to make the number really small. So that's going to have a coefficient that's either a fraction or a decimal. So I'm just going to do a decimal, same thing. So if I put a half in front, you can see it's getting wider. The smaller the coefficient, the wider it's going to get. 0.01. It's so wide you can barely see it. So I'll write that down in a second. That's called a compression. So if you think about a U, compression means you push down on something. If you push down on it, it would make it wider. So that's a compression. So just as a heads up, we will write those translations down in a second. And the last type of translation is reflections. You guys have probably done this before. If I wanted to reflect it across the x-axis, if I put a negative in front, so we put an equal sign, that will reflect it across the x. To reflect it across the y isn't going to really work here because it's already symmetric, so we'll look at that later. I'll show you it in a few minutes. So just so we could visually see those, I think it's a little better than me just randomly telling you all this stuff. So we can now visualize what is happening. So what I'm gonna do is write down those other translations, just so you have them written all in the same spot. And then we'll look at some examples or types of problems that you might see, or that you will see, excuse me, in the future. All right, so I'm just gonna put the other translations kind of right next to it over here. I don't need to keep writing. So we were talking about a vertical stretch. Ooh, excuse me. So if you have a coefficient in front of your function, it stretches if the coefficient is greater than 1. So remember, stretching kind of makes it narrow. And we call the other one a vertical compression. So same idea, you're putting a coefficient in front of your function, but this coefficient is going to be between 0 and 1. So fraction, decimal, something small, so the smaller it is, the wider it gets. And then the last thing was reflections. So in the x-axis, basically if you just put a negative in front of your function, that's going to reflect it across the x. And if possible for the y-axis, depending on the parent function, if you put a negative inside the function, it will reflect it across the y. So we'll see examples of that later. So those are the main translations we'll talk about. The nice thing is you have it all organized now in one spot. So your assignments on Thursday and Friday will relate to this. So please make sure if you're confused, you refer back to your notes. Okay. So now let's see now we have all this information. What are the actual problems going to look like that I'll give you? So obviously you're going to have some assignments. You'll eventually have some sort of assessment on this. Who knows when, but I'll let you know. So let's look at that. Oh my gosh, I'm only at like minutes left. Time flies when you're having fun, guys. Okay. So I might do something like say, I have a parent function of y equals x. So that's linear. That's the most basic function there is. If I said y equals x plus 2, I'm just asking you, how is that being translated? What's happening? Is it moving up, down, right, left, stretch, compressed, or reflected? So you just have to write either up 2, down 2, right 2, left 2, whatever. So I'm asking, what are the translations of those 3 functions? I'm going to give you another example. I'm just going to put it while I'm here. So start to look at the second one too. With the parent function that's a quadratic. So you're basically, the main goal, it doesn't really matter what the function is. I could put weird symbols in there. You're just saying, okay, is it inside, is it outside? That will depend on whether you're moving up, down, right, or left. Are there coefficients? Are there negative signs? So that's the stuff that's going to affect your answers. So literally all I expect for an answer, this you would just say up to, like that would just be your answer and you'd be done. So you don't have to have a fancy answer. But you are trying to figure out all the things that are happening to those, so I'll give you a minute or two for that. So I'll give you another minute just to look those over and see if you can refer back to what we wrote and think about, oh, schnickers, what did I do? Did I? Right, I did take attendance, I just didn't copy and paste it. What was I doing? It's a shame. You stinker. Alright, I'm gonna get one more thing up to show you guys. Alright, so hopefully there's not a ton of work, it's really just starting to recognize how equations are set up. So in this case, I have the parent function of x, there's a coefficient in front. So we would say since the coefficient is greater than 1, this is a stretch. That's all you have to put, you don't need to see if two. The coefficient's kind of affected separately. This one, there's a negative, so you would say reflected across the x-axis. It's on the outside. Sometimes we just say flipped, like you just take it and flip it. The 2 stretches it, and then you just have a thing. So you would just say that. So just kind of quick answers. But remember, this isn't -2. It's negative, which flips it, 2, which stretches it, then the parent function. So then, same kind of idea for the second one with the parent function that's a quadratic. You just have the function and you're adding to the outside of it, so we would say that's up 5. This one, we're subtracting inside the function. So remember, opposite, when you're inside, we would say that's to the right 2. This has 2 things going on. Inside the function, we're moving to the left 1, and then we're moving down 7. And last but not least, we have a negative, which means it's reflected across the x. We have a 3, which is a coefficient. The higher the number, the more it's stretching, so that's a stretch. Inside the function, we're subtracting 5, which means we are moving to the right 5. And there we go. So those are some of the examples that you might see. Another example you might see, because I want to do it quick, because I wanted to show you something before you left today, is I might give you an example like this. I might say the parent function is y equals the absolute value of x. So we haven't done that yet, but it doesn't matter. It's just the original function. It's kind of just like parentheses with the quadratics. So if I asked you, can you take that parent function, can you compress it? You can have all different numbers for compressing, but you just need to know the idea of what goes in front. Can you move it to the right 6 and then up 4? So can you write an equation that all those things are happening? That will be kind of our wrap up. And then there's a few things I want to show you on Le Computer for your assignments. So in this case, you're writing the equation. The other ones, I gave you the equation and you were kind of figuring it out. This time you're writing the equation. right? So you're kind of trying to look for three different things happening. So compression, that was, has to do with the coefficient, and the coefficient has to be between 0 and 1. You can pick any number. I'm gonna pick a half. You put a fourth, a 2/3, 9/17, I don't really care as long as it's a fraction or a decimal. Then inside the absolute value function, we need to move to the right 6, and we said when we're inside the function, we do the opposite sign. So to the right, we're gonna say -6. And then for up, we're gonna be outside the function, and we're gonna add 4. And that's what your final equation will look like. Once again, your coefficient could be different. Does anyone have a question with that stuff right now? Obviously, you're gonna be practicing with this at the end of the week. If there's a major issue, just ask, not a big deal. This is our first real day of notes, so if there's an issue, we'll clear it up. So first thing, my after school, I decided I'm gonna do Tuesdays and Thursdays. I'll be here till 2:30. So obviously on a Tuesday, you're more than welcome to stay in person. You're here anyways. And then on Thursdays, if you're ever at home, I will be doing it in person, but I'll also be virtual. So you can always sign on and ask me a question if you have a question that day. So both days I'll be here, but I'll also be online. So you're always gonna sign in the same way. It's just Sherman Remote is the nickname. So whether it's your full remote day, whether it's a Thursday, Friday, or whether it's after school, just keep it all the same. So a few of your assignments are on Google Jamboard. So I just wanted to show it to you in case you hadn't used it before and what I expect in these assignments. So let me show that to you. Just so you don't open something and say, what the heck are you talking about? That would be unfortunate. So you can kind of put your stuff away, and we're done. This is more just to look at so you're not confused. So I believe you're gonna have this stuff on Thursday. On Friday, you're gonna do a math Excel assignment. So we signed up yesterday, we kind of played around with it. I'll try to put up more detailed instructions, but in general, you should be able to get in. So on Thursday, you're gonna go into your Google Classroom. There's gonna be a few things because these are pretty quick. You're gonna click, it's gonna open like this. Google Jamboard is obviously a part of Google. It's like a virtual whiteboard, so you can kind of draw on it. If it's too small, just zoom in. It's gonna be okay. So I kind of tried to just stretch it out to fit the page, but I can't really read that, so I'm just gonna zoom in. I'll just do 100%. Okay, there you go. Just be careful if you pick this up, it will move. So try to kind of keep it so I can actually see it. Okay, now it's gonna be not my friend. Okay. So it says identify functions. You're just telling me if something is a function or not. That was our warm up today. So it's always just on the pointer. That's not gonna help you. You're gonna go over here. You can pick a pen, a marker, a highlighter, or a brush. I'm gonna do the highlighter. You can pick your colors. I'll just start with blue. So what it's asking me to do is select 2 colors. I'll start with blue. Color all the functions depending on your key. So I'm gonna say that functions are gonna be blue. So I have to make a key so I know. And then I'm gonna say non-functions are gonna be red. Okay. So now I have my key. I'm gonna just go through each of these little boxes and either color it blue or red, depending on if it's a function or not. So I look at this, I have a point, remember that's just points, it's a mapping diagram, -1, -5, 2, -5, 7, -5. None of the x's repeat, that's a function. You don't have to be fancy with it, you can sit there all day and make it nice. You can just go like that, I don't really care, it's just kind of see the color. So you're just gonna color it in based on what the colors you chose were, and you do that for every box. Does that make sense? Any question? If there's a technical difficulty, you let me know. Once again, you can zoom in if it's hard to see. Anytime you sign in, it's always on that, so I always go to right and then get mad. So just make sure you change it to whatever you please and go from there. I'm gonna erase all my stuff because that's my original. Okay. God, that thing scares me. There is another one on
Just as a reminder, we have free breakfast and free lunch at the CAS every day for all students. And at this time, our seniors are dismissed.
Well, not even seniors, so you get to say it in different element. You're also gonna get a transformations maze. I believe it's Thursday.
He's gonna be there so quick.
So same idea, I just kind of scan something in instead of having to print it and then scan it, that's a pain. So I said, all right, we're gonna do it in Jamboard. If you need to, once again, zoom in, feel free. This is a little weird because it starts in the lower right-hand corner, so make sure you start where it says start. So let's say I'm gonna just zoom a little bit just to make it a little nicey. So you're gonna go to where it says start. Or not, okay. Oh, yeah, okay, there we go. Pick a color, I don't care, go to your pen, I'm gonna use a highlighter again, I'll use yellow, it doesn't matter. And you don't have to do anything fancy, I'm just gonna say, okay, this is where I'm starting. And then I'll say what's happening, okay? I have my parent function, there's a coefficient in front, which is stretching it, and then it's moving up too. So you can either go this way or that way, but we said I'm gonna go this way because we have the stretch in the up. So then you go to here, and then from here, you're just deciding, can I go up to the left or diagonal? So don't forget about the diagonal. Or you could go this way too. So you're just following this maze until you get to the end. Once again, it doesn't have to be fancy. You don't like sit forever and be perfect. I know some of you're perfectionists, I don't care. I just need to see the color. So I should be able to open yours, look at it, follow your thing. That's all I really care about. That's what I'm going to be checking. So I just wanted to show those to you in case you've never used Jamboard before. If it doesn't work, we'll figure it out. So just take deep breaths. The one other thing I want to tell you, sorry, I'm trying to rush so I can get it in. On Thursday, you guys will be remote, which is fine. I have a doctor's appointment, so I'm not going to be here in the afternoon. So what I'm going to ask you to do, your assignment will be up. You can do your thing. I'm going to ask you to try to sign on to Google Classroom, to Google Meet at our normal time. If I'm not here, supposedly an administrator is going to do it. I'm not going to believe that someone's actually going to do it. So try to sign on. If no one comes on, it's fine. Don't email me and freak out. You're not going to be marked absent because I'm not even here. So if you please try to sign on. If no one shows up or it's just giving you that error message, you can't get in, just give up and say it's okay. So don't freak out and email me. It's going to be okay. So I just wanted to tell you that so you weren't freaking out if I wasn't magically showing up. So if someone shows up, that's great. If no one shows up, just do your assignment for the day and I'll mark you present the next day. So that is the stuff I wanted to tell you. Sorry, I'm trying to rush. Out of breath. Does anyone have any questions? Fabulous. So you can, my video here. Let me cancel out my Vidski.